So today we'll try to explain you how actually use it, why you need it, why your client need it, and how you can integrate with this. So my name is Elena Kolodyazhna. I work as a technical architect at Magento Professional Services, and with me we have Felix Delval, also from our Barcelona office, and he is architect of Magento Order Management. Our agenda for today. So first we'll have the basic introduction to Magento Order Management, what is this, why you need it, how it works more or less. Then we'll make some quick review of integration layer, and then I will pass this nice clicker to Felix so he can explain the best practices, the best ways how you can actually connect to our system, and some more strategies of integration. So Magento Order Management. It's a SaaS platform. So all code is stored in a cloud. You can use it to store all your orders. It's basically for order fulfillment, to make best from your e-commerce. If your client has different warehouses, if your e-commerce solution has different already extensions to use with different warehouses, it's a big sign that you need order management. So basically we just centralize all your inventories, centralize all your orders in one place, so your customer center can have more visibility on everything what happens with your whole e-commerce. Why actually you need this? We can help you increase the sales, improve the customer experience, because your client service, it will have all the visibility in one place. They can just go to one place, see if there was a refund, was it delivered, was there returns for this order or no. We can help you to add in-store pickup, the ship-to-store capabilities. If, let's say, your client has one warehouse, and also you have just physical stores, and you want to add in-store pickup there. So what you do, you have some stock in one store, but customer wants to pick up from there, and it doesn't have some, I don't know, red t-shirt. So we can help you to make shipment from the warehouse or from another nearby store to bring this item to the customer in shortest term possible. You can save the sale with the endless aisle of products with our order management system. You can have all the visibility on your inventory, like what do you have, which items you have in your warehouse, which item you have in your physical stores, and how is the best way to manage it. And also, if your client has multiple brands or multiple business units, multiple branches, it will help to join everything under one scope, let's say. So, how actually we empower your e-commerce, how the whole architecture looks like. We have our SaaS application, Magento Order Management, and we get all the orders from all your system where it can come from. Like it can be Magento Commerce, it can be multiple Magento Commerce web stores, maybe you have some more e-commerce, maybe you have some Drupal in there. We can get all those orders and centralize them under Magento Order Management. You can have some points of sales like AB Smart solution. You can also take all these orders and centralize everything in one place. You can have any mobile application, iPhone, Android, and again, we will centralize everything and you will have the perfect view on all your orders in one place. Then what can we do with those orders? We take those all centralized experience and we can fulfill your orders from different warehouses, maybe from physical location like physical store X, Y, Z. So you can have view on everything and, sorry. You can have view on all your inventory. And if, let's say, to the customer service client is calling like, oh, sorry, I don't want to pick up from here because I moved, or another location is closer to my work. So customer center can go there, can log into Magento Order Management and go and change the pickup location, change the shipping address. So it's all just to make the customer experience better. What else can you connect in there? As you can see here, all the blue blocks, it's basically the integrations. So our Magento Order is a centerpiece of all your integrations with Magento Commerce, with point of sales, with mobile applications. Again, we take orders, we manage the orders, we take inventory from needed place, and then also, which possibilities more we have? Payments and carriers integrations. So you can manage all the payments through Magento Order Management. if you have, let's say, for warehouse A, you may have one payment gateway used. Maybe from point of sale you use credit card. Maybe for mobile app you have some gift card used. We can also channel this and make it work with your solution. So everything we see here is an integration. So basically the picture how it works is there. Yep. So let's talk about integration more closely. So what's integration? Basically it's just a system which transforms messages from one format to another format of different systems. In our case, when we talk here about warehouse integrations, your warehouse maybe it's Navision, maybe it works with SFTP with XMLs, maybe it works with SOAP. So the main goal of your integration is to transform those messages from our JSON RPC calls to the messages which are going to be understandable for that warehouse system you use. So basically you're writing just a middleware, just converting messages from one format to another format. And our Magento Order Management is using JSON RPC over HTTP, which is designed to be easy and transparent, so it's really easy to use. We'll see some examples later. So how actually you connect your integration to our system? You have this simple JSON RPC registration call. It has just 4 fields. The basic standard approach, you have JSON RPC version there, you have ID, you have methods, which is procedure, which you use. In this case, it's Magento Service Bus Remote Register, because you want to register your integration, so we can communicate with you. And in parameters, you set up just your callback URL and ID of your integration. Is it carriers? Is it payment integration? Is it your warehouse integration? And simple example of how you use the request to our Magento Order Management. It's JSON RPC, nothing difficult. You have ID JSON RPC version. You have method in there, basically the function which you're gonna call. In this case, we call it Magento Inventory Source Stock Management Update. So you send in to us, to Magento Order Management, the stock of your warehouse, so we know where we should fulfill the items from. In parameters, you just send a snapshot. In this case, it's snapshot. In case it's gonna be payments, you say the payment information in there. So it's pretty simple. As you can see here, just to update quantity in specific warehouse, you just put the source ID, where it's gonna be. You put quantity and you put SKU. And you have already stock in our system. I will show later how actually it works on example of Magento Connector. Here we have example of some logistic integration. So when your order comes to Magento Order Management, we process it, we validate it, see if it actually can be fulfilled, if all the items are there, and then if we see, okay, we have the item, we have warehouse when it should be shipped from, and then we go and send a message to your logistic integration, which you write. We request a shipment for the integration. In your case of logistic integration, you just, maybe you have XML in there or SFTP, so you convert this message which we send to you, you convert this in your XML, you put this in your SFTP or whatever system you have there, and you send this to warehouse. Then you wait from warehouse to fulfill the shipment. You wait until they, let's go with example of XMLs already. When they put the XML about successful shipment in the SFTP folder, you convert this and you send it to our Magento Order Management. So we can go and proceed with the order fulfillment. After we receive the message that everything was shipped already, that is fine, we can go and proceed and send the message to your Magento Commerce, to your point of sale, to the sales channel where the order comes from. So you can have in-time updates about the shipment, about the order status, about the line item status. And here we have the example of how it works with the connector. It's just a basic, simple example. So we have Magento Commerce, we have connector on that side, and we have our Magento Order Management. So how it works, you install the connector. Connector is basically, it's just a simple Magento extension, the basic implementation for Magento Order Management. So you install connector, you set it up, you put your credentials in there. When you run Magento Setup Upgrade, it sends the registration call automatically. You don't need to implement anything in there already. After this, you go and let's say create a product. You click on the save, and at the same moment, Magento Connector, it sends actually a request to Magento Order Management to fulfill our database of products. After we have the item in there, you can go to Magento Order Management and you can manually actually update stock in there, or you can send a message, as we saw before, to fulfill, to put, okay, we have such quantities in that warehouse. We have inventory, we aggregate those inventories and send it back to your front end, to Magento Commerce. When you receive inventory, your product, it goes from out of stock because you had nothing there. It receives the update of inventory, it goes in stock, it appears on the front end, so now you can go and buy it. You click, you add to cart, you create a new order, and when new order already created on your site on Magento Commerce, it's been sent to Magento Order Management. So finally, at the third line, it arrives to Magento Order Management and you have order as new created. And after this, we take care about all the fulfillment process, well, with help of your integrations, of course. We will start with a validation process, with a payment validation if you choose to use payment gateways as integration there. And we'll send just all order updates to Magento Commerce. We have post-sales in there already implemented. You can have cancellation of orders and have all the updates on your Magento Commerce and be able to send emails, to update customer, to do whatever you want to make it easier and faster for the customer experience. So, to sum up everything we hopefully learned today. It's a SaaS application, you cannot change anything, you rely on us, you communicate through API. API is simple, you have all specifications in documentation. It's just JSON RPC, we have all specification documentation, it's quite nice, it's quite full now, so we can go and check and rely on it. We have a lot of integration process, documentation, the users guys in there, so we can go and check this. Again, Magento Order Management, it provides you omnichannel and fulfillment capabilities. You can customize it any way you want by your integrations, with the payment integrations, carrier integrations, warehouse, your sales channels, and it's easy transport, it's JSON RPC over HTTP. If it's more or less understandable, we'll proceed to Felix, and he will actually explain more deeply on integration layer how the best way to do this, the best way you can make your integration work. Thank you, Felix.
Thank you very much, Elena. So far we've seen a bit how we're working with order management. It's all about a SaaS platform that we try to extend by integrating with other platforms. So we'll see a bit from an architecture and technical point of view how we can do that. So Elena presented us two examples. We should keep them in mind. The first one was the warehouse management one, where there was like an actual system between the order management on one side and AWMS, or warehouse management system, whichever it is. And the other example, which she presented, was the Magento connector. So there it's a Magento extension hosted on Magento. So keep those in mind, we'll be looking at this, because in the end, they're the same idea and same concept. It's about having a middleware in the middle, transmitting information. So before we talk about more in detail about how this communication proceeds, I'd like to talk a bit about the kind of context we'll be working on when we're working on those subjects. And the first one that comes to my mind is the definition of enterprise software, the way Martin Fowler puts it. So if we look a bit at the list of here, a lot of things should be known to you, like in the commerce world. There's a lot of persistent data. I think that we can all agree on that. Commerce is all about data storing. Cart information, catalog information, inventory. Data is accessed and manipulated concurrently. So it's another thing to keep in mind. A lot of users will try to do the same thing on the same SKU, trying to buy at the same time. So you always have to keep that in mind when you're building this complex system. A lot of user interface screen, that doesn't apply too much to integration, but it's part of the definition, so I think it's important to have it. One I like really much is integrate with other enterprise applications, because in the end, this is what we do here. We're connecting one system to another, putting a middleware, but you never know once you are the middleware, whether you're not the middleware to another middleware. So you always have to think that there's a bigger picture and you're just a little part in it, and that's how you build better systems. Conceptual dissonance is one that is very, very important in this case. We'll be connecting things that were not meant to talk to each other. Some systems that were built in the 80s, some old warehouses in Europe have still those systems talking on CSV files, XML. So we will need to think about how we can actually do that. So we'll talk about that right after. And complex business logic, that I think everybody knows. The second thing we should keep in mind is that we are working in distributing computing, in a sense that there's more than one server, more than one network, more than one administrator. So it's a little mantra that you can find very easily on Wikipedia, the fallacies of distributed computing. And every time you start a new project, it's good to look at them, because making a small mistake on this one can be a big problem on ours, on any project. So the network is reliable. I don't know if anybody has worked with AWS here and know that this is completely not true. The network will go down. Latency is 0. Actually, latency is provided. I mean, if you work on AWS or such cloud services, they will provide you the expected latency from communication from one zone to another. Bandwidth is infinite. Please look at the type of servers you'll be using, the type of network you'll be getting, because this has an import, because we're talking about a lot of data. The network is secure. Always use encryption when possible between communications. So by default, rather you use SSL or TLS on communication. It's not a mandatory, but thing that we're transforming private information, so it's good to make sure that this information is encrypted. Topology doesn't change. The way I mentioned, you never know whether you're the middleware to another middleware. So respect the interface that you're providing, the interface that you're receiving, and be stable to it, because that's the only way you make sure that your system will keep on working. Then less relevant, there is no administrator, and transport cost is 0, and network is homogeneous. So when I start a project, I really like to read those things again, because even though they look obvious when they're written down, it's good to remember them. So communication patterns. So when we talk about an integration middleware, conceptually we're talking about this. There's magic system A on one side, system B on the other, and there's this beautiful arrow that's transverse. But it doesn't tell us exactly how the information is moving from one system to another, because in practicality there's many ways this information could be moving. So the most straightforward way to send information from B to A is actually have the integration middleware be a proxy to it. So typically if you would do HTTP requests, the HTTP request would be sent from system B, proxied in the integration middleware, sent to the system A, whatever process that should happen there, and be sent back. So this type of communication has a lot of advantages, typically because the integration middleware is much smaller. It doesn't need to take care of retry policies or of error handling, or very mildly so, because system B will be transparent that we're connected to an integration middleware here. So we can actually have a transformation layer in the type of the data, but from a connection point of view, system B is directly talking to the system A. So typically here, in those cases, you don't need retry policy because system B should implement it. In the case of the order management, if you implement such a proxy middleware, we have our own retry policy. So in case your final service would not be available, we would take care of resending the message. So by default, this is the best way to do communication. We'll see that there's other patterns, but this is the best way to do so. Interestingly, if system A start to have high response time or start to have some issues, through the middleware, you can actually, using what is called a circuit breaker pattern, you'll be able to have the control on whether you want the calls to go through or not. So this is something that is interesting. Not directly to us, but if you have a chain of integration middleware to be able to break the communication if you see that it starts going over a threshold of response time, I don't know, 100 milliseconds, 200, 500, whatever makes sense to you. But this is in the power of the integration middleware there. The second communication pattern would be what I would call the buffered process. So on the buffered process, the big difference here is that before the message reaches system A, the integration middleware has fully processed that message and is the only one at the moment with a live copy of the message. So system A sends the message over to the integration middleware, it is processed, stored, or whatever else you want to do. System B then gets his response, so in an HTTP mindset. And then afterward is the responsibility of the integration middleware to send the message over and process it on system A. So typically, like, if you would think about writing this type of software in PHP, you probably see here that you would need two different processes because PHP is not threaded. So to be able to give the response to system B and then start communicating, because this is being called directly outside from an HTTP server in PHP, you need to have store it in the database somewhere and start processing sort of a type of a job running the system and passing it over. So in that case, if system A is not being able to be reachable, you are responsible for the retry policy. You are the one that should make sure that the message goes on the other side, because for as far as system B knows, the message has been sent. So that's why it's a bit more complicated and delicate to use this kind of setup, because there's much more responsibility in the integration middleware in that case. This setup is interesting in a case, so I previously mentioned working with old warehouse management system, old system in general. Sometimes they don't have APIs that are as atomic as what we have nowadays, so just one order, or one return, or one refund, where you have to send CSV files with a bunch of orders together, or you have to send a file over SFTP, or whatever. So those are things that you could not do directly through a proxying call, where you need to have it stored and then put on a folder. So there's value to it, but by default, the best type of integration is the proxying. So let's talk a bit now about hosting. So the dream of the enterprise connectivity, the way it was sold in the 90s and the early, like the 2000s, yeah? It was that, yes, you have this mega thing and you plug in everything together and it's beautiful and it hides the complexity. As you can see, it hides it. The problem here is twofold in that kind of setup, is that firstly, the complexity is hidden, but it's still there, so there's still somebody that's responsible for it. And I don't know if you've ever worked with those kind of ESB type of platforms. They're not easy to work with. And the other thing is that if you put your entire ecosystem, and I mean like entire ecosystem, on only one service, when that service is down, it's not a good day for you. So in general, what we advise when we come to integration and communication is to use a more separated patterns, where you would group integration together either by the sending end or the receiving end, and that has multiple advantages. Firstly, they're easier to deploy, they're easier to debug, they're easier to work with, you can scale them because it's a bit harder to scale the big system. This is much easier to have a system that you can scale horizontally. You have better management. So here in that case, typically what we did is integration that gathered by the receiving hands. So you can do it in both ways, either by receiving hands or sending it. So here 1 and 3 are talking to 4, 2 is talking to 5, and 3 is talking to 6 also. So the good point here in that case is just, because you'll be implementing the transformation here, is that you just need to implement it on one side for the receiving system, and then you have the system one directly. The other hand is the one that is reused actually. Yes, we're moving on. So recovery patterns. It's important to think that things will go bad sometime, and we need to be prepared to be able to recuperate the data. So here we are really thinking that there's two types of things that you should be doing in an enterprise software. The first one is logging. So logging is having the list of all the action taken on your system. What is happening to the server, Apache server, PHP server, Nginx, whatever you're running. The action taken by the users, which are there, the messages going through, all of the actions, server up, server down, your user logged in the back office, I don't know whatever you have. And that helps you understand what happened. And this is good, like in case of recovery, to be able to understand what happened. Like this, you can fix it. The second one is a journal. So journal is not useful in the case of proxying, because as we mentioned, all of the messages are on the sending end, not on the middleware. But if you're going to be doing a buffered process, you actually need to journal all of the message. You need to have a copy of everything, because in case there's a desynchronization between the system, you need to be able to know the status of where you were when you left off. because this is distributed computing, so you're going to have distributed information and distributed state also. So the logging will be able to, in case a system went down and you don't know exactly its state, be able to know which message have been sent successfully, where are those messages, and you'll be able to replay them.
Yeah, and also you have in,
Is it working?
Is it working?
Yeah.
So in Magento Connector, you have already implemented journal, so you can use it and see what failed, what not failed, which error were there. So it's it's crucial, almost crucial in working with clients, because you can see what was failing, and you can also retry this message again later. Because we had many problems which can be solved just by having journal on client side.
That's correct. It's a very useful tool in production. Like this, you know, that message, was it sent here? Yes, it was sent here. You get confirmation. Let's put it for journaling. Yeah, so very useful when there's a little crash to be able to do happen. Because when the shipwreck journal says, hey guys, with the terrible storm last night, and that's what happened, it's very different than if the journal says, we found a bottle of rum in the cave. Okay, last one. You need to have visibility because it's a service, it's a pure API service, so you need to have visibility. Please, please, please monitor your integration, know what's going on. This will give you the reason when to scale, why to scale, and you will find out exactly what is being consumed. So depending on every type of integration, every service you use, monitoring is crucial to a service operation. I guess that's not a surprise to anybody, but it's always a good thing to start repeating those. So for the best practices, that's pretty much it. So use proxying if you can, if not, use buffering. Please separate your integration as much as possible. Monitor, log, and journal if you do buffering. So integration strategies. As we mentioned, there was 3 ways to integrate. The first one was the one with the MageCONF connector, which is a Magento 2 extension that you install in your website, that you run there. It's directly hosted on your Magento instance, so it has drawbacks, we'll see about that. The second one is the custom integration. You write your own, we'll see why this is probably not a good idea. And the last one is our integration platform, and leveraging already open source or commercial software already existing outside. So when we integrate through Magento extension, you might have a setup like this, where you have the order management on one side, your payment service here at the bottom, and here in the middle you've got your Magento Commerce instance or Magento Open Source. And in the Commerce, the 2 green boxes would be your typical Magento extension. So payment extension and the MageCONF connectors, they're Magento extensions. So the good thing about that is it's PHP, pretty good everybody at writing Magento extension. It's very hard to kickstart a project. It looks pretty nice in a presentation, but the reality of it is that if you cannot scale horizontally in this setup, you might have problems when there's loads of messages. Your checkout might be affected. So unless you start separating the concerns, it's a good setup to start a project, but it's not a good setup on the long term. So there's still a reason to have a extension being implemented directly on the Magento Commerce. So typically, a good example is payment extension and order management extension. And the reason is the messages that are transmitted there are directly aimed at this instance of Magento. So it's not like if it was using catalog for another brand or for another website, or stock for another brand or another website. The messages that are being received here are the checkout that are being produced on the page, so the payment, the authorization of the payment method, and directly order and order update that are needed for the back office to have some information. So those information are crucial. So in that sense, making a Magento extension to extend is a good idea. In general, it's better separated.
Yeah, and also, why it can work sometimes, if you have separate front end and admin servers, you can just put your extension and enable this just on admin. So in this case, you're gonna separate like front end and admin logic. Like if you have a lot of warehouse updates, you have stock updates coming in there, it's better to have them on your separate server, on admin server. Do not just put down your front end so customer cannot buy anything. If you can separate, separate. That's it.
Very good. So the second type way to integrate is writing your own integration. So you take your favorite IDE and you start working. So let's take this very simple example. We've got a JSON payload and we want to transform it into an XML payload. Let's write the simplest PHP file to be able to do that, and let's see what kind of problem we face to see that it is not that easy in the end. So we said JSON RPC is a post method, so we make sure that it's a post. If not, a post is, I guess it's pretty good. We exit. Then we take the file content from the PHP input, we put into variable body. Then we create a new XML called root. That's what was asked. We walk recursively the params, so that's where the payload of the JSON RPC is. We put that into a temporary, we create a temporary file, we put the content of the XML directly in that file, we write it. It's missing a parenthesis, I see, so it's not going to work anyway. We connect to an FTP because that's what we want to do. We've got a very secure password, as you can see. We write it to a file, and there we go. We've got our integration layer. So this is a very dumb example. I know nobody would write that. I wrote that just to emphasize on the point that, like, here we don't have security, we don't have any encryption, any decryption, there's no error handling. So what happens if typically it's not proper JSON? What happens if we can't connect to the FTP? What happens if the user is not working? What happens if you can't write to a file? There's no logging at all, so it's very hard to know what's happening there. It's not concurrently friendly. I mean, because I write directly to a file called remote file on the FTP. So this is just to make you think that it is not going to be easy to write that code directly yourself. There are some frameworks that exist, some commercial, some not commercial, and that's the one I want to present briefly. So we do not have official recommendation. There are just plenty names. Those are the names that I found doing some research on what you can use for integration. So if you're into open source, Apache Camel is pretty nice. It's a Java-based application. We use it internally for some project. We know that some S are using it successfully. It works as well. There's also MuleSoft. MuleSoft has two different versions of the product. Some is self-hosted, so you run it on your own server. They also have a Heroku, like a la Heroku type of things where you just push some code and it's self-hosted. I don't know exactly how it scales, but I know people are using it, it works well. You can use Amazon Web Services. When you look at the catalog of applications that they have, there's a lot of things that can be done with Lambda or with data processing. They also have, I don't really remember how it's being called. I lose the words. You set up a different list of Lambda, and it's executed one after the other. So you make your whole little path of execution. That works very, very well. SAP has one, and IPIG is a competition to MuleSoft. I just wanted to put that. So, I mean, talk around you. I'm sure many people are using different services, different types. Probably your clients are already using one, or you are already using one internally. It's going to work just fine. But just don't write it your own, please. And just to finish, integration is a skill. That's not me saying so, it's actually LinkedIn saying so. In the hard technical skills is the #1 things companies should hire in 2018. So if you've got some experience on that, it's good to put on your curriculum. It's a good activity. It's going to be useful because the more we're going with services, microservices, headless, Magento, everything's going to be connected through API. So knowing how to connect to systems is a very important skill to have. And that is pretty much it for the presentation.